Hello everyone, and welcome to your partner in education, Agile Rank Mate. Today, in this particular episode of SRMJEEE Search, we're going to be looking at some sample questions of the SRMJEEE exam with their solutions. Come on, let's look at some of them. Our first question is from mathematics. The equation of the base BC of an equilateral triangle ABC is x plus y equals 2 and A is 2, minus 1. The length of the side of the triangle is root 2, 3 by 2 raised to half, 1 by 2 raised to half, 2 by 3 raised to half. Now, our figure is basically, when you look at it, we can see there is a triangle with side A, vertices A, B, C, and this base here, BC, is given by the equation x plus y equals 2, which we can write as x plus y minus 2 equals to 0. And the coordinates of A is 2, minus 1. Now, let's consider x plus y minus 2 equals 0 as equation 1. It is the base BC of triangle ABC, which, by the way, is equilateral. Now, we will apply the coordinates of A for the equation of BC in order to confirm that we have a triangle. So apply 2, minus 1 in equation 1, and basically 2 plus minus 1 minus 2 equals to, well, minus 1. So basically 2 minus 2 is 0, minus 1 is minus 1, which is not equal to 0. Now, according to the original equation, x plus y minus 2 has to be equal to 0 for any point on the base BC. Since A doesn't satisfy that condition, we can say that point A is vertex opposite to BC. Now, what we can do here is find the perpendicular distance of A from line 1. Now, this becomes the height of the equilateral triangle. And basically, we're using the distance formula for a point from a line, which is modulus of ax1 plus by1 plus c over the under root of a squared plus b squared. Now, basically, x is a, 1x is a, 1y is b, and minus 2 is c. So we're going to apply that here. So 1 times the coordinate of A is, x coordinate is 2, plus y is also 1, the coefficient of y is also 1, and the y coordinate is minus 1, and the coefficient that is c here is minus 2. So we'll apply modulus on the numerator, and in the denominator we would have 1 squared plus 1 squared. Okay, so 1 times 2 is 2, 2 minus 1 is 1, and 1 minus 2 is minus 1. Basically, we have modulus of -1 over square root 2. which means that the height of triangle ABC is 1 over root 2. Modulus of -1 is 1. Now, we're going to use the formula for the height of an equilateral triangle. Now, height of an equilateral triangle is always given as root 3 by 2 multiplied by A, where A represents the side of the triangle. Now, let's consider A to be the side length of equilateral triangle ABC. So root 3 by 2A equals height, which we know is 1 by root 2. So we're going to take root 3 by 2 to the right hand side. So on the left side we would have A, on the right hand side we would have 1 by root 2 multiplied by 2 by root 3. So root 2 goes into root 2 times, so we get the numerator as root 2 and the denominator as root 3, which means that the length of the side of the equilateral triangle ABC is 2 by 3 whole raised to 1 by 2. So this particular quantity is the length of the side of the equilateral triangle in the question. So our answer is option D, 2 by 3, the whole raised to 1 by 2. So the idea here is to use the equation of the line. First prove that A is the vertex for the equilateral triangle, and then use that point and the line to find the height of the triangle, and then we use the formula root 3 by 2A equals height, and we substitute the calculated height in order to gain the side of the triangle. So the length of the side of the triangle is 2 by 3 raised to 1 by 2. Now, let's look at another question. The equation of the circle that is circumscribing the triangle formed by the lines x plus y equals 6, 2x plus y equals 4, and x plus 2y equals 5 is. Let's, for convenience, name the vertices as A, B, and C respectively, where AB is made by the line x plus y equals 6, BC is made by the line 2x plus y equals 4, AC is made by the line x plus 2y equals 5. So we're going to find out which of these options is the right answer. Now, x plus y equals 6, we can consider that to be equation 1. 2x plus y equals 4 is equation 2, and x plus 2y equals 5 is equation 3. Now, what we're going to do is we're going to subtract some of these equations in order to find out the coordinates of each of the points. Alright, now for point A, we will subtract equation 3 from equation 1. So x plus 2y equals 5 will be subtracted from x plus y equals 6. So x plus y equals 6, x plus 2y equals 5. So we're subtracting the second equation, so that's minus. 6 minus 5 is 1. And y minus 2y is negative y. So negative y is 1, therefore y equals minus 1. So we apply this to equation 1, which means x plus minus 1 equals 6. X equals 6 plus 1 equals 7. So the coordinates of the point A are 7. Let me just find a way to erase that. the bracket. And so now that I've erased it, let's go back with the pen and write the coordinates. So the point A has the coordinates 7, comma minus 1. Now, in order to gain B, we're going to subtract equation 2 from equation 1. So subtract 2 from 1. So what we get is x plus y equals 6 and 2x plus y equals 4. So we're subtracting all of it. So 6 minus 4 gives you 2. Y gets cancelled. X minus 2x becomes minus x. That means x equals minus 2. We're going to apply that to equation 1 again, which means minus 2 plus y equals 6. Y equals 6 plus 2 equals 8. So therefore, the coordinates of B that we found out are minus 2 and 8. Now, we need to find the coordinates of C. So how do we do that? Well, in order to find the coordinates of C, we need to use the lines AC and BC, which are 2x plus 2y equals 5 and 2x plus y equals 4 respectively. But as you can see, we have a problem. We don't have them multiplied. We don't have a way to eliminate a variable. So over here, what we can do is equation 2 is 2x plus y equals 4. We can multiply that by 2 to get 4x plus 2y equals 8. And we can subtract x plus 2y equals 5 from that. So when we write it down, we will subtract equation 3 from equation 2 multiplied by 2, which is 4x plus 2y equals 8. So 4x plus 2y equals 8. X plus 2y equals 5. Subtraction's happening. 2y gets cancelled. 8 minus 5 is 3. 4 minus 1, 4x minus x is 3x. 3x equals 3. That means x equals 1. So we're going to apply that to equation 3. So 1 plus 2y equals 5. 2y equals 5 minus 1 equals 4. Y equals 4 by 2 equals 2. So now we know the coordinates for C as well. So let's erase the brackets and in their place write the coordinates of C, which are 1, 2. So A is 7, minus 1, B is minus 2, 8, C is 1, 2. Now if you look at these points, they are lying on a circle, since we have a circle circumscribing the triangle. Now we know that the general equation of a circle is x minus h the whole squared plus y minus k the whole squared gives r squared. Now we know that the radii of the triangle are equal. So the distance between O and A, O and B, and O and C are equal. So these three lines are equal because the vertices of the triangle are lying on the circumference of the circle. Now we're going to use the distance formula of 2 points in order to solve this equation further. Distance formula here would be x2 minus x1 the whole square plus y2 minus y1 the whole square. Now, in order to do that, we're going to consider these radii to be equal. So let's start with OA and OC. All right? So since radii OA and OC are equal, that means, by the way, the coordinates of O, we're going to consider them to be h and k so that we can use the general formula of the circle. All right? So since OA equals OC, we're going to use their coordinates for the distance formula. So in this case, it'll be h minus 7 the whole squared plus k minus -1 for A the whole squared under root. And on the other side for OC, it'll be h minus 1 the whole squared plus k minus 2 the whole squared. So basically now, since we have variables, we'll have to obviously expand it in the form of a plus b the whole squared. So what we're getting is x squared plus 49 minus 14h plus k squared plus 1 plus 2k, because minus 1 times 2, minus 1 times minus 1 times 2 times k gives you plus 2k. And all of these are still under the root. And on the right hand side, what we're now getting is h minus 1 the whole squared. So that will be x squared plus 1 minus 2h plus k squared plus 4 minus 4k. So over here, we can remove the roots by squaring both sides. So the first step is expanding a minus b the whole squared. Second step is square both sides. So basically you get h squared plus k squared minus 14h plus 2k plus 50 equals h squared plus k squared minus 2h minus 4k plus 5. So h squared and k squared gets cancelled. We can write the rest of them as minus 14h plus 2h, since this goes to the left, plus 2k plus 4k equals 5 minus 50. So therefore what we're getting is minus 12h plus 6k equals minus 45. Now that means 12h minus 6k equals 45. Now this particular equation we'll consider to be equation 4. So this is when OA equals OC. Now we're going to do the same scenario for OB equals OC. So since OB equals OC, just going to substitute the values right away. So h minus 7 the whole squared. Actually, that's for A. So let me rewrite that. So h minus of minus 2 the whole squared plus k minus 8 the whole squared, coordinates of B, equals h minus 1 the whole squared plus k minus 2 the whole squared. Now I'm going to write the right hand side in terms of h squared plus k squared minus 4k minus 2h plus 5, just to save time. The left hand side, we'll have to do it regularly, like manually. So we have to expand a minus b the whole square. So that becomes h squared plus 4 plus 4h plus k squared plus 64 minus 16k. So taking the square off, what I'm going to do is I'm going to remove h square and k square already, so we can do it easily. We can also remove the square root by squaring both sides. So what we get is 4h minus 16k plus 68 equals minus 4k minus 2h plus 5. So we can take the variables to the left, the constants to the right. So what we're getting is 4 minus 2h plus 4 minus 16. Actually, it's 4 plus 2h, not 4 minus 2h, because it's minus on the right and it goes to the left, it becomes plus. Over here, minus 4 goes to the left, becomes plus. So 4 plus 2h plus 4 minus 16k gives 5 minus 68. So therefore 6h minus 12k equals minus 63. Now let's consider that as equation 5. Now, let's look at both equations 4 and 5. Now, we could technically prove OA equals OB, but we don't really need to do that. We just need to get two equations. And now, by multiplying, by making sure that we can cancel a variable out, we can find out the coordinates of the center of the circle. So 12h minus 6k equals 45. 6h minus 12k equals minus 63. So all you have to do is subtract equation 5 times 2, which is 12h minus 24k equals minus 126 from equation 4. So we have 12h minus 6k equals 45. 12h minus 24k equals minus 126. So h gets cancelled. There's already a minus, so minus times minus becomes plus. Same for the constants. So 12h gets cancelled. Minus 6 plus 24 gives you 18k. Then you would have 126 minus 45. Actually, it's 126 plus 45. So we get 171. So 18k equals 171. That means k equals 171 over 18. So basically we can divide it in terms of 9. So 18 when divided by 9 becomes 2. 171 when divided by 9. So 2 is 18. I mean, actually 1 is 9. And then you have 8 left, and then 81, and then 9. 81 is 0. So the numerator becomes 19. So the value of k which is the y-coordinate of the center of the circle, is 19 over 2. We're going to substitute that in equation 4. So in equation 4, we're going to substitute it. So that is 12h minus 6 times 19 over 2 gives you 45. That means 12h minus 19 times 3. So 27, 1 3 is a 3, 3 plus 2 is 5, so that's 57 equals 45. Therefore 12h becomes 45 plus 57, which is 102, and h equals 102 divided by 12. Basically we're going to divide by 6 here, so 12 divided by 6 gives you 2, and 102 divided by 6, so 1, 6, 4, 2, 7, 42 cancels out, so we have 17. So therefore h equals 17 over 2. So now we know the coordinates of the center of the circle, which are 17 by 2 and 19 by 2 respectively. So how are we going to solve from here on out? So remember, we have radius OC is equal to r. So we're going to find out the value of r first, which is technically the distance formula. So x2, which is O, minus x1, which is 1, the whole squared, plus y2, 19 by 2, minus y1, which is 2, the whole squared, under root. We can use LCM to get 17 minus 2, that's 15 squared over 4, plus 19, since 2 becomes 4 when you put LCM, so 19 minus 4 over 2, the whole squared. So again, that also becomes 15 squared over 4. 15 squared is 225, so 225 times 2 would give you 450, and the denominator still stands as 4. So we're going to consider r to be equal to 450 over 4. The whole of that is under a root. Now from here on out, we're going to put the values of h, k, and r in the general equation of the circle. Now if you remember the general equation of the circle, it was x minus h the whole squared plus y minus k the whole squared equals r squared. When you apply our values for h, k, and r, we're going to get one of these 4 equations. Okay, so let's apply them here. X minus h in this case is 17 by 2 the whole squared, plus y minus k in this case is 19 by 2 the whole squared, and equals to radius, which is r squared, which is basically 450 by 4 under root whole squared. So we'll have to expand in terms of a minus b the whole square on the left hand side. The right hand side we can remove the square root. So that becomes x squared plus 17 by 2 the whole squared minus 2x times 17 over 2 plus y squared plus 19 by 2 squared minus 2y times 19 over 2 equals, the right hand side is 450 over 4. Alright, so the 2's get cancelled from both terms with a minus sign. So basically we can rewrite the equation as x squared plus y squared minus 17x minus 19y. Now at this stage of the equation, we can go back to our question and we can eliminate options A and C because they do not have the minus sign for both 17x and 19y. So we can eliminate A and C. Now we have two options, options B and D, in order to prove. So how do we do that? Well, in order to do that, we'll have to expand these. So 2 squared is 4. We're going to take that as the common denominator. 17 squared is 289. 19 squared is 361 over 4. And what I'm going to do is I'm going to bring 450 by 4 to the left hand side. So basically 289 plus 361 minus 450 over 4 equals 0 on the right hand side. So 289 plus 361 gives you 9 plus 1 is 10, 1 goes over, 8 plus 1 is 9, 9 plus 6 is 15, 1 goes over, 2 plus 1 is 3, 3 plus 3 is 6. So that's 650 minus 450, which gives you 200. So basically the equation now becomes x squared plus y squared minus 17x minus 19y plus 200 over 4 equals 0. So now we got our final equation. 4 goes into 250 times, so therefore x squared plus y squared minus 17x minus 19y plus 50 equals to 0. So finally, we know that it's minus 17x minus 19y plus 50. That's the option which becomes the correct option according to all the calculation that we just did. Let's look at that. Option B has minus 50, which is incorrect. That means option D, x squared plus y squared minus 17x minus 19y plus 50 equals 0, turns out to be the right option. So this was a pretty complicated question. The idea here is use the three equations to find the coordinates of A, B, and C. Then we use the formula of the general equation of the circle. That's x minus h the whole squared plus y minus k the whole squared equals r squared. To find h and k, we're going to use the distance formula for OA, OB, and OC. After getting two equations, we can eliminate one of the variables, get the other variable, substitute that to get both variables of, that is h and k. Once you got h and k, find r using one of the radii equations for this of the distance formula, and then finally with h, k, and r you can apply that to the general equation and find the equation that the question is looking for. So that concludes this episode of SRMJEEE Search. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. For more of our useful and interesting content, don't forget to click the notifications icon present below the video in order to get the latest updates from our channel. So until the next webisode, take care, stay alert, bye-bye for now.